Today is a product and technology launch event. Product strategy is basically the key core of corporate strategy, and a good corporate strategy should reflect where the industry is heading. Let me briefly describe how we see this market. Strategy means looking at today from the future. Strategic capability means being able to find certainty in uncertainty. So from our point of view, from ENSD's point of view, across the charging and swapping industry, what are the real technology trends and what certainties sit beneath them? These are just some of our observations and judgments. Today, we'd like to share them with you, and these same insights have guided our own continued R&D investment and product definition. In China's domestic market, we see a few major structural themes. The first is doubling in 3 years. In 2024, China launched a nationwide 3-year doubling plan. At the time, it targeted urban, highway, and rural deployment. Combined, those three fast charging segments were expected to land nearly 180 gigawatts in total. Based on that plan, the overall build-out cycle over those 3 years would roughly follow this kind of timeline. And 2026, as the second year, meaning this year, is clearly the most critical year in that build cycle. But in reality, since 2024, as the market began to develop, we found that the actual market size was larger than originally planned, and not just a little larger. So where is that extra demand coming from? In fact, starting in 2024, the market saw a new breakout growth driver, heavy-duty trucks. So what the industry is showing now is the road network expansion framework, plus the rise of electric logistics and heavy-duty trucks, creating a stacked market structure. And within those two structures, over here, we keep hearing words like ultra-fast charging and flash charging, and over there, megawatt-class systems, and so on. Behind all of that, what is the shared certainty? It is the move toward higher power. The entire charging and swapping industry is steadily moving toward higher power. And in fact, higher power is not just a trend in our industry. It is really a broader trend across the global intelligent economy, because behind it, a huge amount of equipment worldwide is becoming smart and data-driven. Even something as simple as a smartwatch, once it becomes intelligent, carries much more computing and consumes much more energy than a traditional watch ever did. So as the world moves forward, the trend toward higher power is everywhere. What is the second certainty? Last year, in 2025, the industry introduced to national level certifications, mandatory certifications. One is 3C, the other is the Energy Efficiency Standard, and the Level 1 Energy Efficiency Standard was introduced there as well. It clearly set a minimum quality threshold for this industry, along with higher order performance requirements. And we believe that this is also a reflection of a much bigger macro direction. Once the 15th five-year plan unfolds, the goals for overall economic development. And when the 15th five-year plan is completed 5 years from now, there will be several key metrics for evaluation. And the very first one on that list is high-quality development must deliver clear results. That is a hard assessment target. As everyone knows, across China, when the whole country mobilizes to drive development, these kinds of key policy indicators are very likely to be achieved. So from that, we see a second clear certainty embedded in the market. The move toward high-quality development, and high-quality development does not simply mean building something that does not break. That is only the baseline of the baseline. It means improving overall system-level performance for every industry, including charging and swapping. It raises both the floor and the ceiling. It sets a very clear upward direction for the sector. That is why our industry now has these mandatory standards. Then, if we look at overseas markets, because right now they are also at a moment of major change, the first thing we look at is expected incremental demand. Across the world today, which markets are growing the fastest? Southeast Asia and the Middle East. But beyond growth rates, beyond incremental growth alone, we also have to look at absolute size. If I start at 1 today and become 2 tomorrow, that is 100% growth. It looks fast, but if it is 2 compared with someone else's 200, then the meaning is limited. So if we look at expected growth in absolute terms and at this year's absolute outlook, Europe is still far ahead in total market volume. But if we look a bit deeper and take Europe out and then look at Southeast Asia as a whole to surpass the US in absolute development volume. So what we can see now is this: Europe and the US still matter, but Southeast Asia will become the key battleground. That is a very clear shift in the market landscape. A market, no matter how large it is, if it does not undergo structural change, may not be ours. The opportunity, it is like starting a business today. If you were asked to invest several more billion in a smartphone company, most people would not do it. Why? Because that market, while huge, already has a very stable structure. Only when the structure changes do real market opportunities appear, and backed by Southeast Asia and a series of emerging Belt and Road markets. It is very likely that companies could emerge there. Much like China once produced players such as StarCharge and Tailed, we believe that within a few years in these markets, several giant companies may rise again. The only question is who will capture them. At the same time, there is another factor here that differs from Europe and the US. Chinese products in Southeast Asia have stronger influence and stronger penetration. Your competitors may also be Chinese. They may also be Chinese companies. Everyone is backed by China's industrial chain and manufacturing capability. So this means when facing these emerging markets, we will inevitably compete overseas. And what sits behind that? We believe it is timing, the window in which Southeast Asia, South Asia, and Belt and Road markets become the main battleground will be very short. So overall, we believe 2026 will definitely be a year of reshaping the landscape. And we also believe it is not just a landscape year. It may well be the last landscape defining year for the entire charging and swapping industry. What it opens up over the next few years may become the industry's final major window of opportunity across the whole industry. There have only been 3 major windows. The first was the early subsidy cycle, when every charging power was subsidized. The other one. The second wave came around 2020 with the electrification of buses, and not just buses. It was a broader electrification of public transportation as a whole that included taxis and ride-hailing fleets. Plus the first wave of passenger all of them in that period saw a major growth opportunity. And now we believe the market is entering its third growth wave. It is driven by the 3-year doubling plan, plus the overseas overlay and the rise of heavy-duty logistics trucks. And once those 3 pillars are built, because this market has a classic infrastructure nature, serving both people flow and freight flow. Once the infrastructure is in place, the landscape does not change easily. Just look at gas stations across China today. It is hard to imagine any structural market shift there once the market becomes fixed. Then no matter how large it is, it becomes much harder to disrupt. Think about these cycles across those 3 cycles. In fact, the first 2 cycles each created new entrants, powerful new players, either charger makers or module companies. So at our launch event 2 years ago, we made a prediction. We said the charging and swapping market was moving on a 6-year cycle, with the winner decided in 3 years. Now that 3 years have passed and we have reached 2026, the trend we see is extremely clear, and we are seeing it unfold in an even faster and more powerful way. But there is another side to this market. It is highly competitive, and in a market like this, it is critical to know where your line is, because in the trends we just discussed, there is also the demand for high quality development right now because competition is so intense. We are already seeing a series of quality compromises. We call them pseudo-innovation. That includes cut down overclocked versions. You give up part of the voltage range and only optimize for one part of it, so the cost can be pushed down. The problem is that 3C becomes much harder to obtain. There are also high temperature dirating versions. A product may run for the first 40 minutes or 1H and still output 400 kilowatts. But once the temperature rises, it drops to 300 plus kW. That is a high temperature derating version. There are also test-only special versions. During testing, they meet level 1 efficiency, but once they run at an actual site, they drop to level 2 or even level 3 efficiency. All of these are, in our view, not helping site builders or operators truly put long-term returns first, faced with harsh competition and internal pressure. Some people chose what we call the path of pseudo that puts the whole market under pressure. The question is, with tighter regulation and fiercer market competition, how do you still break through when the market gets this crowded for ENSD? Our answer is simple. Turn the blade inward. Drive value through scientific R&D and look to innovation for real solutions. We have never avoided market pressure. We are, in the truest sense, a technology innovation company. We have to face the pressure and we have to win through it. We have to be bold enough to win, even in fierce competition. But the way we win is not through pseudo that drains the real long-term interests of the entire value chain. It is by taking the right path. The right path is never the easy path, but we still choose it. We face the market pressure head on, and we still aim to win the competition. That is the standard we set for ourselves. That is why every step in our product and technology releases has been decided in exactly this environment. So now we officially move into our product release section. Chapter 1, No Limits to Scale. we just talked about several clear market directions, higher power, higher quality, and several others as well. When those trends land in the charging module segment, they point to a few clear directions too. One is higher power, larger power. Another is higher stability. Another is higher efficiency. And then what else? Higher compatibility. Can a charger keep upgrading smoothly over time? All of these factors must be considered together in module design and R&D. So if we look at the market before 2026 across the charging and swapping industry and the development of charging modules, these are all the mass-produced products already on the market if we map them by output, with power on the horizontal axis and efficiency on the vertical axis. Then if you look at the top right corner, the products that have truly entered mass production are basically all ENSD products, either the higher power models, such as the 60 kilowatts plus products that we have had in the market for years, or our ultra high efficiency, ultra series products. So how to push both efficiency and power higher has always been one of our key R&D priorities. And when it comes to high power products, ENSD has gone through 3 full years of real world market validation with more than 100,000 units deployed nationwide across all kinds of scenarios at scale and over long periods. And through 4 generations of product iteration, that is what helped ENSD become the #1 brand in global market share for high power charging modules, because only we have taken 60 kilowatts plus products through the market in the truest sense, with full scale sales and full scale iteration. So we know better than anyone what high power module products really have to go through. As everyone knows, when module power goes up, moving from 30 kilowatts to 40 kilowatts is only about a 30% jump in power. But moving from 40 kilowatts to 60 kilowatts, the design challenges are no longer means a 50% increase. That is already a different class altogether. And once in the product design process, the power level nearly doubles, something that scales linearly with it. There are 2 major challenges. The first is all kinds of stress, such as thermal stress. Take a component in the same cooling environment and loss condition. If the power level doubles, then very often the thermal stress it faces can rise by 2x or 3x. So how do you solve that in design? And beyond that, there is also airflow related stress, plus voltage stress and current stress. Once the power level rises, or 40 kilowatts products, you realize that many of the design methods you use for 30 kilowatts and many of the protection methods you relied on might only fail after 3 to 5 years at lower power. But once you move to 60 kilowatts and above, or even higher, because wind speed and air pressure rise so much, what happens? Problems that once showed up after 3 to 5 years can now show up in around 1 year over the past 3 years. We have really seen that the high incidence point for issues is around the 1 year mark. And at that time, it was extremely painful for us because that product design had already been completed 1 year earlier. Where do the stress limits appear when a high power module scales up? And what is the second major design challenge? The second big challenge actually comes from the higher current caused by higher power. As we all know, when current rises on a traditional technical route, if you build a 60 kilowatts unit, each phase of a 3-phase Vienna carries 20 kilowatts at 220 volts. The theoretical current is 98. That is a huge current. And many of our peers on traditional architectures have tried to engineer around it. They say, we'll bring in 380 volts. But even then, the current is still over 58. That is still a very large current. So what do you do then if one shoulder can't carry it? You add more shoulders. So they start paralleling devices. From a technical point of view, that means adding more components to handle the huge stress. Once those devices are paralleled, the system complexity rises very quickly because it works a lot like a 3-legged team race. If any one person falls, the whole system may collapse. And as complexity climbs, it turns into 6, 9, even 12 people tied together. Controlling system complexity becomes dramatically harder, which leads to an exponential drop in long-term stability. So these 2 major design challenges mean that when power doubles, the whole system starts to struggle. It takes a lot of real-world experience to build strong high-power module design capability. So today, backed by the industry's richest high-power module design experience, ENSD brings you the first product of this launch, Keyming 80 Ultra. Its overall conversion efficiency is 97.5%, ensuring level 1 energy efficiency certification. In other words, ENSD does not build modules below the level 1 standard. That is our internal product design rule. For every efficiency level you lose on a heavy-duty truck charger, your annual net profit can shrink by around RMB 10,000. That is a big number. So when you choose equipment, if you do not choose level 1 energy efficiency, the little money you think you saved may be gone within 2 or 3 months. So ENSD's 80 kilowatts product combines the high efficiency of our 40 kilowatts platform with the same efficiency level, and also draws on our design expertise in high power modules from 60 kilowatts and above. All of that adds up to an outstanding product. The 80 kilowatts module also fully adopts double-sided potting. It is built for all kinds of harsh conditions, especially heavy-duty truck sites with high dust and heavy pollution. On double-sided potting, I want to stress again and make this very clear. ENSD's 80 kilowatts product is not a cut-down overclocked version and not a high-temperature derated version. Standing here today, over the past roughly 2 months, I have personally tested almost every product on the market that has reached the sample stage at 60 kilowatts and above, especially the 80 kilowatts units now being sampled. It is fair to say I tested almost all of them. Some peers, even whether for confidentiality or because they had too few prototypes, would only send them out and allow customers just 2 or 3 days of testing. But we still did everything we could to test them. And after testing them, I can say that above 60 kilowatts, almost none can truly do this. Once you get to 80 kilowatts, it is almost a total wipeout. It is extremely hard to achieve for an 80 kilowatts product. On the module side, the charger must serve all vehicle voltage ranges. Can you really deliver across all vehicle voltage platforms, no matter what vehicle shows up? Can I still output 80 kilowatts? I cannot say that with one vehicle, I give it 80 kilowatts. But when another vehicle arrives, its voltage point changes, and I drop to 60 kilowatts or 40 kilowatts. That means your vehicle compatibility is not good enough. ENSD can deliver continuous constant power output at 80 kilowatts from 300 volts to 1000 V with no gaps. And to be clear, this holds even at 55 C. It works even under high heat. But in our real tests, most competing products showed one thing: lots of voltage dead zones. In other words, some vehicle ranges were simply given up, and that was only at room temperature. This already happened there. Once temperature rises, you do not even need 55 C, starting around 40 C. A lot of operating points start derating. Now, beyond the vehicle side, beyond the car-facing end, we also need to look at grid-facing capability. Our grid is really 10 kilovolts step down through a transformer to 380 volts into the charging station. So grid fluctuation is normal. And within that normal fluctuation range, no matter how the grid moves, your charger still has to deliver stable power to the vehicle. You cannot say the grid moved a little, so now my vehicle charging is unstable. That is not acceptable. And what I saw in testing on this point was shocking. That really is the word. Shocking. What did our real tests show? At 55 degrees Celsius, we can handle 380 volts input at plus or minus 15% on the input side, and our modules and supported chargers can still deliver a stable output power. But what we saw in the market across a large number of charging modules is that once they reach 80 kilowatts, their range narrows to what? It narrows to just 5%. And this is without high heat. Even at 25 C to 35 C, basically room temperature, it has already narrowed to about 5% variation around 380 volts. Then the output power drops sharply. Do you know what 5% means? 360 volts. When I saw that, I could hardly believe it. I thought, how dare this product be sent out broadly to customers for sampling? 360 V means that in China's lower tier cities, especially in factories and mines and other high power usage scenarios, if not half the year, then at least 30% to 40% of the time, that voltage point appears for long periods. Think about industrial power at 380 volts. A small drop to 360 volts is extremely common. So if you buy this kind of module and this kind of charger, what does it mean? It means that after you buy it, perhaps half the time, you will face frequent high rate derating. So for a charging system, one side is about adapting to grid fluctuation, and the other is about vehicle compatibility. Both must deliver stable output before you can truly help operators. And charging equipment companies hold the most important quality line. This is just the 60-point baseline. So how can operators avoid this trap? You may say, I do not understand the technology. You do not need to just remember two things. First, on the vehicle side, require that under high temperatures, if it is a 400 kilowatts charger, it delivers constant power from 300 volts to 1000 volts. Then it must be 400 kilowatts. If you insist on that, you will not get burned. On the vehicle side, then on the grid input side, require that under high temperatures, and honestly, not even 55 degrees Celsius. 45 degrees Celsius should already be enough. At 380 volts plus or minus 15%, or at worst, plus or minus 10%. There should be no derating. Normal grid fluctuations should be no problem. Different vehicle types should be no problem. Is this not simply what a charger is supposed to do? But when I look at many peers on this point, I do not know what they are thinking under price cut competition. Because in reality, what is being lost here is very real, very direct quality. If you ship even the 60-point baseline away, then as a charger company, you will understand very quickly in such fierce competition. For example, in a B2B tender or head-to-head evaluation, if you know your competitor is using that kind of 80 kilowatts module, as long as it is that type of 80 kilowatts, then fine. As long as your bid document includes the industry's long-standing 60-point requirements, which have always been written into tender documents. They are there every time, always there, as long as those are included. They are out, then you will be at a huge disadvantage in competition. Back when we made 40 kilowatts modules, everyone could do this. Pick almost any company. They could do it. Anyone making power supplies, anyone doing power conversion knew this was a basic passing line. But now in today's market competition, people chase margin. So they say, forget it, leave it out. Grid fluctuation, forget it. I just will not talk about it. Most customers do not know the technology that well and may not know the design details, so they keep quiet. But losing even this 60-point baseline is a major loss. We believe ENSD cannot do business like that. ENSD has a responsibility to help the whole industry hold the 60-point baseline. Not everyone should strip away all the basics, because when the tide goes out, it shows everything. The size of our 80 kilowatts product is exactly the same as our 60 kilowatts unit across the market. We have dozens of partners who design their sheet metal around our 60 kilowatts or are still in the process of 3C certification. So with our 80 kilowatts product, you can upgrade seamlessly. There are also two common questions about 80 kilowatts that I want to discuss briefly. One is 400 kilowatts power sharing between guns, the issue of uneven split charging, because 5 modules at 80 kilowatts make 400 kilowatts. On this point, we actually have another configuration we recommend for lower power heavy duty truck systems in the few hundred kW range. We suggest 320, 400, and 480 kilowatts configurations. This solves both total power and split gun issues. For example, a 400 kilowatt system can use for 80 kilowatts units plus 2 40 kilowatts modules to solve split charging. That way, this whole product series can use one sheet metal design covering the full range, and it can still deliver lower overall cost across the lineup because the cost per watt of 80 kilowatts is clearly much better than 40 kilowatts. So this is one recommended product adaptation strategy for heavy duty trucks. The second common question is, can an 80 kilowatts module only be used for heavy duty trucks? I have asked many of our charging equipment partners, and their first reaction is usually yes. They say, look at the size of this module. Its dispatch granularity also suggests that it belongs more in truck charging sites. But that is just inertia talking. ENSD's 80 kilowatts module, because it delivers constant power across the full voltage range, can also help you significantly cut costs at public fast charging sites. For example, for a 640 kilowatts charging stack, we recommend you 680 kilowatts units plus 440 kilowatt units that solves both coverage and granularity. Why? Because the difference between 80 and 40 is also 40. Using that 40 kilowatts step together with the standalone 40 kilowatts modules, you can switch back and forth between them so that the public fast charging site still basically keeps 40 kilowatts dispatch granularity. And for a charging stack like this, our rough calculations show that if per gun charging demand stays within 250 kilowatt hours at this kind of site, you will find that this configuration covers more than 80% of typical scenarios. You will not run into dispatching bottlenecks. So for sites where single gun demand below 250 kilowatt hours already represents maybe 80% of public fast charging scenarios, because at a typical public fast charging site, single gun throughput is not low, but it is not a truck station after all. So with this kind of adjustment, it does not affect the operator's real on-site dispatching needs. But think about it. How many charging modules do you need now? It becomes 10. With 40 kilowatts modules, you needed 16. That is 6 fewer modules, even after considering the cost per watt gap between 80 kilowatts and 40 kilowatts. Overall, you create about RMB 10,000 in extra gross margin. That is RMB 10,000 more gross margin per stack, as long as the 80 kilowatts unit still supports the low voltage range and guarantees constant power from 300 volts to 1000 V. If that is secured, then even in public fast charging, for part of the single gun scenarios, you can significantly cut single pile costs and improve margin. So our Kimming 80 Ultra delivers overall conversion efficiency at the level 1 standard, backed by our years of high power design experience. Its double-sided potting protection, 0 W standby power consumption, all combined to create a step change in value for both charger makers and operators. After the launch, you can apply for testing, and the immediate installation service is also available. That is our 80 kilowatts product. But this is only what I would call the appetizer. To be honest, ENSD launching an 80 kilowatts product is not really a surprise. Everyone saw it coming. We launched 60 kilowatts 3 years ago. So for us, 80 kilowatts was only half a step away. But there are deeper product questions that need to be considered. What module power rating? What power granularity will the market truly accept? That really depends on two discussions. One is the total power of the charger itself. As total power keeps rising, the market naturally wants higher power modules too, so the system structure stays simpler and costs do not rise too fast. From what we see now, the move toward megawatt class chargers is very clear, but in that process, around 3 megawatts, you start to hit a bottleneck. In other words, this is mainly because a transformer application is usually around 2.5 megawatts at a time for one transformer node. So below 3 megawatts, whether 1 megawatt, 2 point something MW, or anything under 3 megawatts, these will be the mainstream design range. As you know, at 2 megawatts, 3 megawatts, if you still use a 30 kilowatts or 40 kilowatts module, it starts to feel undersized. And once you go beyond 2 megawatts, there is clear pressure pushing us to make module power higher, but beyond total power. What else matters? You also have to think about the use case. For public fast charging sites, we believe that today, 40 kilowatts is undoubtedly the optimal dispatch granularity, but in the mid to long term, it will move toward 60 kilowatts. Why? As passenger EVs keep getting larger battery packs, and as solid-state batteries enter deployment, there will be a force pushing the optimal dispatch granularity toward 60 kilowatts for heavy-duty truck charging sites. Today, a 400 kilowatts charger already gives 200 kilowatts per gun. Think about that. 200 kilowatts per gun. So in truck charging scenarios, the demand clearly moves from 40 kilowatts to 60 kilowatts to 80 kilowatts, and even beyond 80 kilowatts. That demand is very clear, which brings us to ENSD's second launch product, Kimming 100 Ultra. It is the first in the industry to launch a 100 kilowatts module. Its overall conversion efficiency is 97.5%, still helping charger makers and operators meet the national level 1 energy efficiency standard. Power goes up, but our efficiency does not go down, and its size shares the same platform as our 60 and 80 kilowatts units. That is what we call a smooth upgrade. Choose ENSD from 60 kilowatts to 80 kilowatts, all the way to 100 kilowatts. One design path takes you upward. This is part of our effort to make product upgrades smoother for all our partners. As you know, a 100 kilowatts product is ideal for whole number system ratings. Think about a 400 kilowatts heavy duty truck charger. 4 modules and you are done. Just for modules. From design complexity to dispatch complexity, everything drops sharply. 600 kilowatts, 6 modules, 1 megawatt, just 10 modules. The structure becomes very simple. And for megawatts ultra-fast charging, it is absolutely a perfect teammate. Think about it. For around 2.5 megawatts using 40 kilowatts modules, you need dozens and dozens of modules. Now with this, you can build it with just a little over 20 modules. So design costs can drop sharply so today, by launching the 100 kilowatts product first, we bring outstanding value to our charger customers and operators and deliver a product that still protects the quality baseline. And again, let me stress, even though this is ENSD's 100 kilowatts product, it is still not a cut down overclocked version and not a high temperature derated version. We help the industry meet both grid adaptation and vehicle adaptation and stay well above the 60-point line. No matter how fierce the competition becomes, we must defend the industry's baseline. Now let us continue the launch event. Chapter 2. Looking up to the summit. We've talked about the big. Now let's talk about the high. Where should we begin? Let's start with a discussion we once had with a customer. What were we discussing? We were discussing an immersion cooling solution. Some of you may know it. some may not. It means immersing the module in liquid. It is different from liquid cooling. Liquid cooling uses a cold plate. Immersion means the module sits directly in the liquid. So we explored what issues this product design would have, what challenges it would face, and what benefits it could bring. And if the market truly has that demand, then what is really behind this? So we had to go back to first principles and ask, why does the customer really need an immersion product? First, they definitely want strong protection, high IP65 protection, shields it from the outside environment, and they also want lower noise because liquid-based products are still much quieter than air-cooled ones. Then why not just use liquid cooling? Liquid cooling also has that benefit, right? Because they want something cheaper than liquid cooling. Liquid cooling is too expensive. So if we go back to the customer's original line of thinking, these are the things they really need. I felt that discussion was very insightful beyond the day-to-day side of running a business. It gave us a deeper understanding of the real product need. So I told him then, I said, I hoped we could meet that more fundamental need in a different way, because what the customer needs is not a better horse carriage. What they truly need is a better, faster way from point A to point B. So ENSD has a responsibility to open up our industry's product innovation in more dimensions. Today's launch will bring several very different kinds of products. We will bring a product with peak efficiency, a product with ultra-strong protection, and a product with extreme quietness. Peak efficiency, ultra-strong protection, extreme quietness. Some of you may have noticed this is not 3 products. It is one top-tier product with all 3 unmatched performance advantages, which brings us to the third product of this launch. Sirius 40 Max. Before this, ENSD's products were all in the Kimming series over the past 2 or 3 years. Whenever people mentioned ENSD products, it was always Kimming something, like the 80 kilowatts and 100 kilowatts just now. Kimming 80 Ultra and Kimming 100 Ultra. The Sirius product is our super cost-effective offering for the mid to high-end charging and swapping market. So what makes it exceptional? What comes next? It's not just a milestone for ENSD. I would say it is not only a milestone for the charging and swapping sector. It may well be a broader milestone for the entire power conversion field in this new era of energy development. Sirius 40 Max has a peak efficiency above 99%. This truly deserves applause. And why do I say that? Not because I need applause. It is because I deeply hope this applause will honor our R&D and technical teams. From this moment on, the entire power conversion field has entered a new dimension because you need to know what sits behind this 99%. I have written out the 4 limiting conditions behind that 99%. Once you see them, you will understand how valuable it is. This is with 380 volts input. This is a 40 kilowatts product. It is real, tangible, and ready for mass production. This is an AC-DC conversion product. It is not some DC to DC product. It truly completes AC to DC conversion, and it is an isolated power supply. It is not a non-isolated product. Even with those 4 conditions in place, it still achieves 99% conversion efficiency. At the full system level in this power range, that is extraordinarily valuable. You need to understand what that means. Take a copper cable, just 10 or 20 meters of copper cable. When power travels through those 10 or 20 meters, efficiency can already fall to 99 point something, maybe 99.5%, but Sirius is an extreme engineering challenge. Current does not just flow through a copper bus. It also passes through many components, and those components must meet a whole set of high precision design standards. And even after those standards are met, the system still has to run stably under highly complex conditions and in charging and swapping. It also has to withstand heavy interference and deliver stable output year after year. So the engineering difficulty is extremely high, and under those conditions, guaranteeing 99% conversion efficiency is extraordinarily hard. I once watched an interview documentary. A veteran mountaineer said, above 8,000 meters, every 100 meters forward, the risk I face and the huge energy I spend are far greater than running 5 kilometers on a normal plateau at 2,000 meters or 3,000 meters. In power conversion, every 1 percentage point higher means an exponential rise in difficulty. Let me give you an example everyone can relate to. Last year, in October 2025, China introduced its energy efficiency standard. How many truly mass-produced level 1 modules can be submitted for testing today. Not many. You can count them on one hand. And where is that level? It is around the 96.5% to 97% range. And even that has pushed the whole industry to its limits. So you can see how hard this really is. That is like being at 4,000 meters run in Lhasa and you already feel altitude sickness. That is already hard enough, right? Just think about running in Lhasa. It really is hard because altitude sickness is already very real. But if you want to pull that up to 98%, you are already above 6,000 meters. That is professional mountaineering territory. And our 99% is firmly in the 8,800 meter zone, pushing toward the summit. Before room temperature superconductors are industrialized, before that day comes, ENSD has the world's highest power, conversion technology and product. We are driving the whole industry toward the edge of the physical limit, and our series product has 99% peak efficiency and 98.5% weighted overall efficiency. It keeps overall charger efficiency above 98%. That is absolutely world class. So this is not just level 1 energy efficiency. It goes far beyond level 1. We are not just helping you protect the line anymore. When this product is tested, of course it will qualify as level 1, but it is not level 1 because that is its true limit. It is only because level 1 is the highest current standard. We want a super energy efficiency class. We want a titanium grade efficiency class, just like in other power conversion fields, because we are clearly at the World Summit. So as you know, every efficiency grade difference can mean RMB 10,000 in net profit. So correspondingly, a series product with 98.5% overall efficiency over 1 year can bring to heavy-duty truck operators RMB 30,000 to 40,000 in net profit. And how much does a 400 kilowatts truck charger cost to begin with? Second, our series product is a true IP65 solution designed to ensure that harsh environments are isolated from our charging module and the entire charger. That is its protection mechanism. In other words, it is on the same level as liquid-cooled and immersion solutions. And the third strength is equally exceptional. IP65 Super Protection, our series product, is a fully natural cooling product, so its operating noise is 0. It is fully naturally cooled, which means within a normal module footprint, we achieve natural cooling. So of course it is ultra quiet. And on top of that, it helps the entire charger save a lot of fan-related hardware because the fans are gone. So it's ultra high conversion efficiency, the IP65 level protection that comes with it, and the all-silent design we just mentioned. The full natural cooling design, when this product first took shape, I actually had another exchange with that customer. He challenged me on the logic. He said, what you said is actually right. Stepping out of the box does not necessarily mean using immersion. I have used many IP65 protected products, including liquid-cooled products, and also a niche type called independent air duct products. They are all IP65, but inside, component temperatures are still very high. Yes, they block outside interference, but because component temperatures stay so high, after 2 or 3 years, they still fail. So the question is whether you can truly suppress high temperature. I can give you a very complete answer. Why can Sirius solve this problem from the root? As you know, with traditional technology, overall conversion efficiency is about 95%. If we raise our overall efficiency to nearly 99%, that means total power loss or energy loss drops from about 5% to about 1%, reduced by 4 or 5 times. If under traditional conditions, a component relies only on natural air radiation cooling with no extra cooling at all. The formula is there. We calculate this rigorously. We are engineers, after all. If that component has 10 watts of loss based on its surface area with 10 watts of loss, it will run at around 135 degrees Celsius. That is a very high temperature. If a component keeps running around 135 degrees Celsius, then after 2 or 3 years, it will fail even without outside interference. Now, if that loss drops from 10 watts, reduced by 4 or 5 times, what does that become? About 2.5 watts. And if nothing else changes, still under natural air radiation cooling, 135 degrees Celsius drops to around 50 degrees Celsius. First, treat the root cause not the symptom. Why do components run hot? Because the energy loss is too high. When we push efficiency to the extreme, and energy loss drops sharply. Under the same thermal environment, we have already brought temperature down from 135 degrees Celsius to around 50 degrees Celsius. But is there still heat at that point? Yes, there is, because heat is still radiating through air. So we add a whole series of internal series solutions for all kinds of components, including irregular shaped components, thermally conductive encapsulation materials, plus our heatsink, proprietary process and turbulence technology. Once all of these work together, the roughly 50 degrees Celsius level drops further to around 35 degrees Celsius. So step one is lower loss 135 degrees Celsius to 50 degrees Celsius. Step two is thermal process optimization, 50 degrees Celsius to 35 degrees Celsius. So the answer we deliver today is this: at room temperature. After 1 hour of continuous full load operation, the temperature of these key components tops out only in the 60-something degree range. And if you factor in high ambient temperature operating at 55 degrees Celsius, after a 30-minute and 60-minute, you will find the hottest point is only in the 80-something range. Do you know what 80-something degrees Celsius means? With traditional technology, even under normal room temperature, as you just saw, component temperatures were already above 100 degrees Celsius. So our Sirius product under these extreme conditions, after 1 hour in a high temperature environment, still keeps component temperatures far below what other technologies see, even at room temperature. In other words, its component temperature is even lower than liquid cooling. We bring the best stability to all of you. Our high-end products, especially overseas models, will continue to include most flexible hole technology. This is the new technology we launched at last year's event. In a traditional module, say with 28 chips, if any one chip fails, the whole machine is effectively down. Once it fails, power drops from 40 kilowatts to zero. That is like a charger, instantly losing dozens of kilowatts. But for us, if any one chip suffers a failure or fault, this 40 kilowatts unit only drops to 37 kilowatts. It falls back to 37 kilowatts and still outputs stably. So if a 1 megawatt charger runs into a problem, at that moment, it becomes 997 kilowatts. The site almost does not feel it. It does not affect the operators, business or revenue at that moment. For our overseas products, we will still include this across our various models because overseas labor costs are high. So with the Sirius product, we are truly returning to first principles and rethinking what the industry really needs underneath. We are not making a better horse carriage. We want to return to the most fundamental need, how to deliver a better product, a genuinely higher dimensional product, into the hands of customers and make this industry different. So the entire Sirius line is aimed at the mid to high-end market. Notice, not just the high-end market, our Kiming series serves the entry and mid-range market. Sirius serves the mid-range and high-end market. There is some overlap between the two. It depends on what customer demand the product design is targeting. So if you have strong demands for a quiet operation, high protection, overseas high-end market needs, or high energy throughput needs, then Sirius is made for you. Now let us compare our Sirius-based chargers with liquid-cooled and immersion chargers. First, power conversion efficiency. Those two are just cooling methods. They have little to do with conversion efficiency. Their conversion efficiency is still second tier or third tier. So you can think of them as maybe doing a solid 60 points. We are at 99. So of course, we win decisively. No matter what we compare against, we win decisively on energy efficiency returns, protection level. All three are IP65. All are IP65. So that is a tie. Structural complexity. As everyone knows, liquid cooling is very complex. So for many charger companies, building liquid-cooled chargers is very challenging. It requires strong design capability. Immersion is slightly better than that because it does not require all those cold plate loop structures. But the complexity is still high because after all, there's still a lot of liquid inside. Sirius, on the other hand, gets a full score. Why? Because aside from looking like a standard air-cooled module, it removes all the fan structures. There are no fans. So its structural complexity drops sharply. And what sits behind that? It means we dramatically lower the design barrier. Charger design capability no longer needs to be so strong to handle a top-tier product like this. Then there is operating noise. They are decent to definitely better than air cooling, but maybe they are around a 7 out of 10. Noise is roughly 60 decibels. We have no noise. Next, cost control. Liquid cooling is simply expensive. Immersion can be a little better, but in general, it is still more expensive than air cooling. Our cost is definitely far lower than liquid cooling. As for after-sales difficulty, as everyone knows, both liquid cooling and immersion are very hard to service. Once leakage happens, it becomes a major problem. And years later, when you need to replace the liquid, even skilled technicians are hard to find. For us, maintenance is much easier. It is basically like a standard air-cooled solution. And because of the full natural cooling approach, overall, after sales, difficulty drops even further. So against liquid-cooled and immersion products, you can say we almost win across the board. Then compare us with overseas products. Overseas, there is a very strong competitor in the push by Chinese charging companies into the high-end European and US markets. This is an absolute heavyweight rival. Alpitronic holds nearly 40% of the European market. Its peak conversion efficiency is 97.5%. So it is a very powerful competitor. Now let us compare against it. On the right is its charger. Its module is a very large air-cooled unit, taller than a person in protection level. Sirius is IP65, while theirs is air-cooled. So we clearly do better there. Operating noise, we have no noise. The air-cooled unit still makes noise. Cost reduction. Our manufacturing cost is far lower than overseas products. After-sales difficulty is even lower for us. Ours is just the size of a standard basic air-cooled module. Energy-saving returns. Alpitronic is already excellent at 97.5% peak. As we just said, its peak is 97.5%. We can help the charger exceed 98.5%. That is more than 1 point higher in conversion efficiency over 1 year. As we said, that is another RMB 10,000. Series 40 Max with our 99% conversion efficiency, over 98.5% overall conversion efficiency, full natural cooling, IP65, and a flexible hold system brings the world's top performance together into one product. In the simplest possible way, it lets charger design fully integrate world-class technology and lift the industry's overall quality upward. I will not speak for other fields, but we are confident that in the mid to long term, in the charging sector, liquid-cooled modules can retire. I want to return to the source and ask one question. Why do you need a liquid-cooled module? Why pay more for liquid cooling? If you say, I want stable operation, why stable? Because it gives you IP65 protection. Fine, we solve that. Because internal component temperatures are lower. Fine, we solve that too. And ours is even lower, right? You want lower noise. Ours is lower too. So almost every fundamental reason for needing a liquid-cooled module is fully met by us and exceeded. And on top of that, the product we build is far more energy efficient. So here in chapter 2, looking up to the summit, Series 40 Max brings the industry to the summit of efficiency. So chapter 1 was about the summit of power, and chapter 2 is about the pinnacle of energy efficiency for the entire industry. Now we enter chapter 3, the final chapter, mountains connected. Let me begin with a question I am often challenged with. When will ENSD start making chargers? First, let me be very clear. ENSD will absolutely not make chargers. ENSD has its own B2B focus. Deep down, we have a clear positioning for ourselves. ENSD is not merely a charging module manufacturer. How do we define ourselves? What do we want to do? We want to be an innovation leader in new energy, in the world's second great wave of electrification. ENSD is EN5. Technical roots itself is not just a charging module technology. So in our strategic map, in ENSD's vast horizon, there are many fields where we can contribute, where we can deliver real value to society and to these industries. To put it plainly, everything upstream and downstream of chargers does not rank in our top 10 strategic priorities. We do not have time to do it. It does not rank higher. Because of our positioning, our strategy is not there. We need to look toward the broader direction of global development. The world has many major opportunities and trends, but there is one that I think everyone agrees on, the huge opportunity of the AI wave. AI is reshaping the world at an unprecedented pace and transforming every industry. So for the AI infra market, for AI infrastructure, ENSD launches the Polaris series. For the AI era, the traditional data room power path looks roughly like this. 10 kilovolts grid power goes through a transformer and becomes 380 VAC, then through MDB and ups, all the way through. After passing so many devices and so many stages, it is still at C when it gets here. Only at the very end, at the PSU stage, is 220 volts AC converted into about 50 VDC or 48 VDC, and isolation is down there as well. What is isolation? It means if something goes wrong on this side, it should not affect the other side. If this side blows up, it should not affect that side. That is the basic idea. Isolation is completed here. Only then can the DC power enter the server cluster. You can see how many steps it goes through. What is the problem here? In the early days, it was manageable, but as AI compute keeps rising and power keeps increasing, there are several hard barriers that cannot be crossed. First, energy loss is too high because it goes through too many stages. Second, copper usage is too high as voltage keeps dropping to such a low level at this very low voltage point. If you want to keep current and efficiency under control, you need a huge amount of copper. That means massive metal usage. Third, the footprint is too large. Look at all this equipment, space that should have been used for compute boards is occupied by the power system. These three big problems constrain the rise of total AI power. So what is the opportunity behind the HVDC we talk about so often? HVDC means trying to compress this whole sequence into one step or at most two. That is where HVDC, ACDC comes in. So once power comes through the transformer at 380 volts, it can go in one step to 800 volts DC, completing AC-DC conversion and isolation right there, all in one step. Then from there, through a DC-DC stage, you convert 800 V down to about 50 volts. That dramatically reduces intermediate stages. That is the opportunity of HVDC. Going one step further, the hot topic now is integrating HVDC with a transformer ahead of it. That is SST or solid-state transformer. Put those together, and you get a solid-state transformer. When solid-state transformers are fully deployed, power from the grid can go through a solid-state transformer and enter the server room directly. The path becomes extremely short, and the footprint drops dramatically. The core technology ENSD is bringing today is focused on HVDC products, a market that is already mature and growing rapidly. Powering AI is different from charging EVs and EV charging. What is the main technical challenge? You need to keep high efficiency across many different voltage points. When a charger serves different vehicles, you cannot have one car save power while another wastes it. The focus is on the differences caused by voltage variation. But for AI power supply, the data center basically wants 800 volts. It does not keep changing. There may be some storage stages that still need other voltage points, but the main output is 800 volts. So what determines energy loss? It is not voltage swinging around. It is light load and heavy load difference. What is light load versus heavy load in a product built on traditional technology? Look at its peak efficiency. I've marked it around 97.5%. But the problem is this. When that power supply is under light load, say a 40 kilowatts unit outputting only 10 kilowatts, it becomes very power hungry. Or when this 40 kilowatts unit is at full load, it can also be power hungry. Only when this power supply runs around 20 something kW is efficiency relatively high. That is the nature of the technology. But when AI models are training, the main workload sits in the heavy load zone. And once training is done, for example, after a model is trained, when we ask Dogo a question, Dogo, analyze the power supply market for me. That is inference. And inference mainly runs in the light load zone. So whether you truly save power is not just about peak efficiency. It is not about voltage difference either. It is about how long you spend at light load, how long you spend at heavy load, and how long you spend in the middle. So the energy loss of AI server power supplies is strongly linked to light and heavy load conditions. And this is exactly where ENSD's M5 technical route is unmatched globally. So we are launching two products. And with these two products, we formally announced to the world that ENSD is entering a completely new track, a new field. One is Polaris 40 Pro. It has 98% peak conversion efficiency. This efficiency directly benchmarks the world's top HVDC model today. From Delta, its peak efficiency is also 98%. We can benchmark directly against it. But note, that is only peak efficiency. Its combined efficiency across light and heavy load is definitely lower than ours. So compared with others who already do this well, while our peak is also 98%, our overall efficiency is 97% 97.5%, the highest in the world, until you get to the other product I am about to mention. The second product is Polaris 40 Max. Its peak efficiency is above 99%. Its combined light to heavy load efficiency is 98.6%. It is absolutely unmatched globally. In other words, our overall efficiency is already much higher than others' peak efficiency. So the gap in energy loss here becomes enormous. Take a 1 gigawatt large AI data center. The annual power saving difference can reach 350 million kilowatt hours per year, equal to 200 million RMB in net profit. So this is a massive difference in energy consumption. It also brings a major reduction in PUE, and with full natural cooling, with no fans. It can greatly reduce ongoing operating issues caused by fan failures. Our 40 Pro does have fans, while our Max is. At the same time, it saves substantial rack space. There is one more point. Microsecond level dynamic response ensures high quality power output. We do not need this in EV charging, because basically, if a fluctuation happens, as long as we protect the vehicle and protect the charger and nothing is damaged, if it recovers within 1 second, then from the EV owner's perspective, charging is almost unaffected. It just returns to normal. So the rhythm of current and power quality control does not need to be quite that extreme. But in AI servers, it is different. A fluctuation of 1 second is unthinkable. Even a few hundred milliseconds can affect the computation on the other side. The AI would suddenly get dumb. That is unacceptable. So in iServer power systems, it is not a stop-start scenario. Once the power supply turns on, it is expected to run continuously for 10 years. And throughout those 10 years, every fluctuation must be controlled with great precision. So the AI server power field is not just about hardware. It also requires a complete rebuild of the computation algorithms and control logic. In this process, we invested massively in R&D to provide world-class products for the HPDC opportunity in AI. So Polaris 40 Max with 99% ultra-high conversion efficiency, microsecond level current control, and a natural cooling system that sharply lowers PUE, delivers performance unmatched globally. It represents Chinese companies reaching the absolute summit of this field today. So ENSD is here to power China's AI future and the world's AI future. And we are also looking for partners worldwide, because ENSD will remain focused on core technology. Just as we do not make chargers, we want to share the system opportunity with our partners and build world-class integrated systems together. So Chapter 3 of ENSD's launch event, Mountains Connected, takes us from new energy into a new era of AI energy, where new energy and AI move forward together. New arena, new summit. Thank you, everyone.